Hello everyone, welcome to Knowledge Optimizer. I am Rajat and today we are going to learn about adapter pattern. So adapter pattern is again a structured design pattern. So what it does is basically converts when you are dealing with the kind of interfaces that are different. Basically the implementation is different, but the client isn't aware about all these things, and it basically calls a function. Now when you are dealing with incompatible basically interfaces classes, then you just have to provide a response to the client, so it would be a black box for the client. So whenever you want to deal with basically incompatible type of interfaces, then you basically kind of create a basically you can say a layer, a black box, and you do all the logic where you are just making it compatible for the clients to integrate with all other interfaces without knowing like how it is going behind the scene. So basically to give you a small example, like you want to create a you want to, if you have seen a function, basically you just get epoch, the time in epoch. Okay, now you can provide the timestamp is in sorry, you can provide whatever the input you have done, you can provide it in string, integer, basically hour, minute, but whatever you will get in response back, that would be epoch only. So the internal implementation, like what it is doing on the basis of what you have provided, the what the information you have provided, basically try to find like the what would be the implementation of it in the backend. Then you it further basically map to that implementation and provide the response to clients. So basically you can think of it as a library. It is basically used whenever you are dealing with a library. Adapter pattern is the one that you have to use. So we'll go to the definition also. It's the same. It allows incompatible interfaces to work together, acts as a bridge, converting one interface to another. Okay, so to explain you more, suppose uh, like in the e-commerce only. So whenever users select like PayPal option, or you can say credit card option. Now in the PayPal, it basically, or Paytm you can think. Okay, now in the Paytm, it's basically the UPI you have to scan is the process you have to do, while in case of credit card you have to swipe. Okay, swipe or add card information. So these are the two different implementation of it. Basically for processing the payment, these are the two different implementation, whether you want to swipe or whether you want to scan. Okay, on the basis of what user is selected. So what it will do, basically client will just make a call here. Now it would be a black box for client. In the end it would be just be payment processed. Now what it would be doing here, suppose client is calling process payment method, and there it is providing whether it's a Paytm or credit card. Okay, Paytm or credit card. On the basis of process payment, like there would be two different implementation. One would be for PayPal. It would be doing internally the scan part, while one would be for credit card, it would be doing the swipe part. Okay, but in the end the response they both would be returning to is payment process, and there would be a single function the client would be calling, that is process payment. So we'll see the same through an example. Okay, before that let's see the structure of it. So structure is simple. There would be a client interface through which the client would be interacting. Like in our case, that would be just a single method, process payment. Now there would be different adapter on the basis of, like it is a credit card adapter, then Paytm adapter, and there would be different implementation on what type of data has been provided by the user. And further at the end they would be calling like process payment. Like in the end it would be just payment is processed. So key components like the target, adapter, adaptive, client, I won't cover them. I think I'll just explain it through the code. Okay, so suppose this is the adapter pattern. So what we have done is here is basically two type of payment method we have supported: PayPal, okay, and then Stripe. This is a kind of, there is a function for Stripe that is charge, while for PayPal, suppose the function is the process, basically the way it is processing it is pay, and for that it is charge. Okay, they are two different things. Now since client is not aware of this, it won't call the pay for PayPal, whereas Stripe for that. So it will basically call process payment method. It will just call this for method. Now on the basis of like what is the user has provided, like the mode it has selected, on the basis of that further process payment function would either do what it has to do. In case of PayPal it has to pay, in case of it has to do charge. Okay. So in the main function, what we have done is basically created two payment method object. Now we have created two processors, basically adapter I'll say, and then we are just calling the payment process payment method. So this is a payment processor, both are of payment processor type. So to give you brief understanding, what we are doing here is, so here is a client. Now suppose from the user, basically no, yeah, client is user only. Suppose he has selected PayPal option. Now he has done PayPal, sorry, payment processor dot process payment, sorry about that. Dot process payment, and here it has provided payment mode. Now it's the part of this library, you can say library of black box, what to call, whether it has to call pay method or it has to call charge method, and that would be done on the basis of payment mode selected. So you got the basic idea. Client will always call this function only, payment processor dot process payment. Now the internal implementation would be part of this. So the main use case of it is when you are dealing with library only. So whenever you are doing any refactoring, okay, okay, we can see like where do we use it. So whenever you are doing any third party library integration, so you have seen like some common code is we try to extract out, and it would be the part, it would be kept as a part of third library. Okay, so whenever you are building any library, this adapter design pattern is used there, even the third party integration whenever you are doing. So how it does is basically it take the response from many different microservices, that library. Suppose client has asked for something, it has taken different response from different microservices. Now the whatever the client is expecting the response, it will convert whatever response it gets from these microservices, it will convert that response into basically what is required by the client into that response model. So just the transformation is the part of this. Okay, now whenever you are doing system refactoring and you want to integrate new classes without changing the existing code, compatibility layer, all three are nearly same, it's just whenever you are adding any library. So oh, we forgot to play this. Okay, I'll just run this code. So I got this processing payment through PayPal, through Stripe. Okay, now we have written the same code in Java. So we have created two payment mode, PayPal and Stripe. Now we have payment processor. Now we have two implementation of this, the two adapters, PayPal adapter, Stripe adapter. Here in the main code, what we are doing, just creating this, these two payment, initializing them, then creating two adapters. Now we are just calling uh, process payment method, both the adapters. Okay, I hope that's all from this video. I hope like if you still have any doubt, you can just comment in the comment section below, and let me know if you want the code of it. I'll just upload it to GitHub. Okay. Thank you.